All right. Let's start with the fourth lecture. In this lecture, I will talk about processes that change the social division of labor, that develop it, so to say. And this goes directly to the theory of growth, seen from a perspective of the social division of labor. So this is not completely your standard economic growth theory, as it is done in neoclassical economics. It's a little bit different, and it really is relating growth to what I already mentioned, namely institutions, increasing returns to specialization, and the infrastructure itself, the social division of labor itself. So, and I refer back to the last week, we talked about the crisis of 2008. The core argument was that the social division of labor deepened, as I called that. Now, I will talk here in this lecture now very much about the deepening of the social division of labor as a very important tool for increasing the economic wealth in from the social division of labor. Yeah. All right. So let's go to the overview of the different things that create this wealth, right? Increasing returns to specialization obviously are related to the creation of wealth. If you can improve that, if you become even more productive than you already are, that is economic growth. Yeah. So it's a very classical type of economic growth, right? Consumptive smoothing is also an element of this economic wealth creation. This relates to trade. Well, this relates to trade efficiency and lowering barriers to trade and lowering costs related to trade. Yeah? I again refer to Brexit as the negation of that in some sense. And then those institutions, there are always these institutions in the background at work. And if we can improve our institutions, we also improve our wealth creation, and we can increase our wealth collectively. Yeah. All of this are the main building blocks for that social division of labor. And all of it relates to how we can improve wealth creation and how we can change wealth creation. So it all comes down to that architecture, so to say. So what is then the foundation for increasing returns to specialization? That's the first question that I want to ask. And then there are two logics to this increasing returns to specialization. This is an old idea in economics, this increasing returns to specialization, something that was abandoned after the marginalist revolution in the 1870s. But before the 1870s, this was very much at the front of theorizing about the economy by these classical political economists. And there are two perspectives coming from this debate in some sense. And the first one we can call the Ricardian logic. The Ricardian logic is that wealth creation, productive abilities are talent-based. It is the individual talent that determines how productive you are. I'm a very talented farmer. I'm very good at farming, and I know that because I have these innate abilities. They belong to my personality, and as a consequence, I'm extremely productive. Right? This has been from very early on seen as a major source for increasing returns to specialization. So Plato, Aristotle, Greek philosophers, they already referred to this. But it is also very much in the forefront in Ricardo's thinking. And later on, it was picked up by the marginalists and neoclassical economics. So it became the viewpoint that productivity was related to individual abilities. So you individualize these abilities in some sense. And it has nothing to do with the society or how the society is functioning. Opposite to that is this viewpoint that actually it is not individualist at all. It is collective. It is based on the society. It is socially determined how productive you are. And that is called the Smithian logic. And Adam Smith was the first one who really pointed this out. And he stands by himself a little bit. Marx does not pay a lot of attention to this reason why they're increasing returns to specialization, for example. But Smith stands out in that regard. And it is something extremely plausible. Society determines how productive we are. We are learned, literally are learned to do certain things in certain ways. And we base ourselves on a collective knowledge. There's a common collective baseline of how we do things. And that is communicated to us through an education system. And we learn that over time when we grow up, how to do certain things. That is the Smithian logic. And it is not based on talent at all. You learn how to do things and you are embedded in how we do things, right? It is part of this embeddedness that I refer to. It is part of the institutional makeup of our economy. So we have two logics. The Ricardian logic fits extremely well with methodological individualism, and as a consequence, it became the cornerstone of traditional market economics and international trade theory as we know it. The Smithian logic fits extremely well with this social perspective, this institutional perspective, the perspective of institutional embeddedness, of how society functions and how we create wealth together in an economy. And I adhere very much to the Smithian logic as a consequence. I really believe that our society, by and large, is based on a collective knowledge, and that we change that collective knowledge over time by individual actions, by individual contributions, and our education system, and that we are created by that system, by that society, by that how we are educated and how we are learned how to do things. Of course, individuals have talents. Some people are really good at certain things. However, that is not the cornerstone of wealth creation. It makes wealth creation a little bit better, because a very talented person can make major contributions to the institutions of the economy by telling us how to improve productive tasks, for example, right? So we know these high-flying entrepreneurs that were very successful and high-flying scientists that were very successful, and they made major contributions to our understanding of how things should be done. For example, Henry Ford introduced for the first time automated production, the production line. So you have a moving production line, and people did very specialized tasks on this production line. He was the first to use that in a factory setting, in the production of the T Ford, the T model that he developed. And he became the most successful entrepreneur in the 1910s and the 1920s. He dominated completely the car market at that time in the United States and worldwide, more or less, because he was so good at producing at a very, very low cost, relatively, these cars. And so he had a very low cost base, and he could ask there for a very low price, and they were sold like hotcakes, these cars. And so he made millions of them. It was the most successful model of car ever produced. Maybe the Volkswagen Beetle beat it later on, but that was much, much later. He changed how we do things, because that idea of the production line and the efficient production by moving things around, moving the products around and keep people in a certain place, completely changed production processes in a lot of industries. And it is very common now. And later contributions were even to make that even more efficient and more effective than already Henry Ford had it. So individuals can, based on their talents and based on their insights, innovate and become extremely entrepreneurial. But it is the communication of that practice that makes us collectively better. If you just have one individual doing something better than others because they're so talented, like a concert pianist, that's nice, but it is only nice when we can make recordings of it and sell a lot of copies of it. Otherwise, it remains very limited, the impact of what this person contributes. Anyway, so I really believe that in the Smithian logic as the basic foundation of our economy, and that the talent stuff is the icing on the cake. But the cake itself, that is this mundane, relatively low productive individuals like ourselves doing things. Yeah. All right. So, you know Ricardo's theory, especially from international trade, of course, because it was developed in the context of countries that trade, not individuals that trade, but it can easily be applied to individuals as well, especially in the context of social division of labor or specialization. That is the theory of comparative advantage. So you look at your comparative advantage based on your individual talents, based on your productive abilities, your individualized productive abilities, and you seek the most productive way to do certain things. And that leads then to the theory of comparative advantage, as it is called. It's not absolute advantage, so to say. And that applies to the social division of labor as much as it does to international trade. Yeah. But productivity is tied with this individual talent element, and that is not necessarily really very good. There's a second consequence to the Ricardian perspective from a theoretical point of view, and that is this marginalist understanding of labor. What is the productivity of labor? Well, the marginal theory of productivity refers to the marginal productivity, the marginal product of an additional unit of labor. That is directly coming from Ricardo's theory. He was the first to develop this perspective. He was the first to really set out the idea of marginal contributions to something, one additional unit. Very innovative for his time and groundbreaking. And he can be seen, therefore, as a precursor, a very, very important precursor to this marginalist theory, that was so much developed in the 1870s in the marginalist revolution. And that is at the foundation for neoclassical economics, as we call it, or market economics. So it was also the first step away from having a understanding of collective enterprise, right? A communal effort to create wealth, right? It became individualistic. The study of wealth creation became individualistic. It was one individual adding one additional unit of labor to the economy, and what is then the productivity of that? That became the cornerstone for understanding the productivity of society, taking us away from this collective understanding that we are in this together and we're creating stuff together. Yeah. All right. So it ultimately resulted in neoclassical economics, this whole thing. Yeah. Contrary to that is the Smithian perspective. The Smithian perspective is that the social division of labor, our productivity, is a collective project. It is something that belongs to the community and fits so well together with what I said so far, namely that institutional perspective on things. Yeah. So our productivity is completely based on how we operate the society as a whole. Our productivity is part of our common knowledge, as it is also called, right? It is part of what we know together, and it is part of what we teach each other and what you learn. That is what it comes down to. Yeah. And you can therefore summarize it as a simple phrase. All of us stand on the shoulders of the ones that preceded us. Yeah. We are improving our abilities. We have increased productivity because we do things slightly different from what past generations did. And we are learning over time, and we're still improving, doing things more productively, improving everything, whether that is how we operate things, how we, our understanding of engineering, our understanding of materials, the physics of everything. All of these things contribute to how we conduct things. Yeah. So our differences between individuals, it's not interpersonal, right? It is not based on that you are more productive than I am, right? I'm productive in a very different capacity than a bin collector, right? It is really incomparable in some sense. I would not know how really to compare what a bin collector does in the context of what I do, namely this teaching of this this module, for example. So it's not interpersonal differences that drives us. It is the social matrix that society provides that drives us. It is power relationships. So the salary of a bin collector is not determined by his marginal productivity. It is really determined by his standing in society, his ability to negotiate with the council about a salary, about a wage. And it is notoriously weak, this position, right? And so his salary is low. And councils are have a bad time as well compared to the government. So the council funding is a problem. All of these elements together provide a weak position for a bin collector to negotiate a wage. And that compares then to myself and to, let's say, the vice chancellor of the university. Yeah? So the Smithian perspective automatically translates very easily to a more collective perspective, and that collective perspective translates quite easily to also a Marxian perspective, and a perspective based on the exercise of power. Now, power I will come back to, because this is a completely central element to the network theory of production. Right? As soon as you write down a network, or you draw a network of a production system, you immediately encounter this issue of control and power. This social matrix there is a framework for framing productive abilities and framing how we are doing things together. And it fits extremely well with the Smithian perspective. That is all I want to say at this time. We will come back to this in length. Yeah. All right. So equality, when we talk about equality and well-being in this context, right, in the Smithian context, it is all about equality of opportunity in the social matrix. Yeah. The other thing is that the Smithian logic is so completely consistent with this embeddedness of economic agents in the system of governing institutions. So governance fits so well with this perspective. And it fits so well with the idea that we all assume roles in the social division of labor, and that these roles are socially determined, and that we are playing a role in this collective process. It all goes extremely well together. Yeah. Yeah. So it fits exactly extremely well with what I talked about in the first hour in lecture 3, this axiomatic theory. I believe that the Smithian logic is the only one that really fits with this. Okay, let's now turn then to this. What is driving economic development in this society with its social division of labor? Right? And that refers then back to the three underlying principles of wealth creation. The first is the one that we all know, technological progress, namely doing things better, by learning to do them better, by using new tools, by increasing productivity on an individual basis, so to say. This is based on entrepreneurship. This is in particular called Schumpeterian entrepreneurship. Right? Schumpeterian entrepreneurship refers to the ability to really improve your productive abilities directly and enhancing your production set or your production function. Then with regard to gains from trade, there are two elements that refer to that, and that is population growth. Population growth just increases the mass of economic agents on which you can base your society. And so you can have a more perfect social division of labor by just increasing the population. Secondly, the increased population will give you the tools, the ability to enhance the social division of labor in other things, because we just become more people and we can do things differently as a consequence. And this refers then to the deepening of the social division of labor. And we already looked at this last week when I talked about the 2008 crisis and the modernization, as I called that, of the mortgage provision system in the United States in the 1980s in particular. That was a deepening of that mortgage provision system. And this is then referring to the deepening of a social division of labor. We simply introduce more commodities, new socioeconomic roles, new professions, new specializations related to all these new commodities. And we create wealth in that way. We enhance our productive abilities collectively in that regard. We have to do this together. Many people are involved, many institutions are involved, many changes have to become together to allow this deepening to happen. And then, of course, institutional development. This refers directly to institutional entrepreneurship, namely introducing new ways of doing things or simply new instruments. Not in the sense of commodities or specializations, but ways of doing things. So, for example, one of the recent examples that we have is, of course, the euro. The euro was introduced in 2000 as a monetary instrument in the Eurozone of the European Union. And it was an explicit innovation, an institutional innovation that was introduced by governments. It did not have anything to do with socioeconomic roles or with commodities. It was replacing certain commodities with something new, namely the old currencies in the Eurozone, the marks, the francs, the guilders. They were all replaced by this new monetary unit, the euro. It's a wonderful example of institutional innovation. Of course, over time we learned that the whole setup of the euro is not that great. It doesn't function that well, but that is a side remark. It is innovation, and innovation, by the way, can also be bad. Right? There is no guarantee that it is progressive innovation that always happens. It can be regressive innovation. I refer to Brexit, which is obviously failing. It's a huge failure. It is innovation, but from an economic perspective, of course, it's a super disaster. And everybody predicted this, but of course, economic arguments were trumped by political arguments that are outside the economy, so to say, or perceived outside the economy. And yeah, it is a great example of also of innovation. Of course, it is innovation, but of a, in my opinion, regressive type. Right? Progressive versus regressive innovation. It is all possible. All right, so I will dwell quite a bit now on this deepening. And the deepening is so much a Smithian form of innovation. It fits so well with the Smithian logic, the logic of a collective understanding of production based on roles and commodities and all that. Right? Technological development, however, is so much Ricardian. Right? It is all about the individual abilities, even though this technological development might be something social based on something new. It is still very much a Ricardian thing and fits extremely well, therefore, with neoclassical economics. What I will do now is I'm going to illustrate all of this through a sequence of examples. A sequence of examples in which I execute certain changes, and I go one by one over certain changes, and we see how certain changes lead to changes in the functioning of the social division of labor. And in particular, of course, I will try to measure the use value that is generated. And of course, there are some remarks to be made with this measurement. Again, I assume that there is a social preference for goods and for the things that are produced. Therefore, I impose social preferences through a social utility function, a social welfare function. But you can also think maybe of subjective measurement of the use value that is generated. But the standard way to look at things in economics is so much based on social welfare. Also, when you have individual utility functions, the aggregation of these utility functions into a social welfare function is a very standard technique of measuring overall wealth, overall welfare in an economy. Before I start with the examples, are there any questions about what I just talked about?
I had a question. Thinking about the Smithian way of looking at development, is it any similar to what uh, uh, to how Paul Romer explains endogenous growth? I saw a lecture of him in which he gave an example of light bulbs and how they led to more innovations. So it had a exponential function.
No, the light bulb example is a slightly different story. Here you refer to that one innovation leads to another, but the source of the innovation, what is that? What he is talking about is collective entrepreneurship in some sense, which, you're right, fits extremely well with Smithian understanding as well. But the Smithian understanding is the understanding of increasing returns to specialization, not the improvement of that. The increasing returns to specialization is, why am I more productive when I specialize than when I'm not specialized? Where is that coming from? Where is that ability coming from? And that the answer to that is collective. It is not individualistic. It is not based on individual talent. I am good at growing potatoes because I learned how to grow potatoes. I went to school, or I was an apprentice, or a farmhand with a farmer, and I learned there how to farm and how to grow potatoes, right? I was not born as a potato farmer, and I did not learn that just by myself, so to say. I based it on a collective knowledge. What the light bulb is referring to is how the collective knowledge is enhanced. You see the difference? Am I clear?
Yes, I get it.
Okay, so you have to distinguish the how do I learn to be productive from how do we enhance the productivity, right? One is referring to a kind of existing world. The other is referring to changing that world, growth. And of course, Romer's theory is about growth. And Romer's theory indeed tries to capture entrepreneurship, which is always missing from traditional growth theory. Entrepreneurship is never really explicitly there. So Romer's theory, for which he got the Nobel Prize, is really referring to try to bring in this idea of entrepreneurship into growth theory. But the Smithian perspective goes very well together with entrepreneurship theories, but the Smithian perspective is really about the sources for the increasing returns to specialization themselves. All right, before I have another small break, just to catch some breath, let's set up the basic example. The basics of the example will remain the same, and I will take this world that I make through a set of modifications, and we will see how that enhances productivity and enhances the total generated use value in this society. There are again two goods. We always work with two goods because when you do three, it becomes suddenly very complicated. Two goods, let's say root vegetables and meat. So we go back to the world of the hunters and the gatherers. Yeah? And in this world, there are therefore two professions: gathering profession, gatherers, and they produce 6 units of roots and 0 units of meat. And then hunters, they produce 4 units of meat and 0 units of roots. Yeah, so we describe them as little vectors, production plants, they're also called. I forget here in this example about autarky. There's no autarky in this example. The initial population of this tribe is 20 members. There are 20 economic agents in this example. And in this world, I will impose population growth, technological innovation or technological development, and deepening of the social division of labor. Yeah. So we will go through the motions of this world in that regard. Yeah. Throughout, I assume one particular set of institutions of how things are done in this tribe. And I'm just imposing that in this world, there is a boss, a chief, who just imposes on this tribe an optimal social division of labor to optimize the social welfare. And the social welfare is described by the common utility function. Yeah. And this utility function is the one that I describe here. So Stone-Geary again, is the one that we had before, in which there is a preference for X, and that is the root vegetables are the favorite type of food for individuals in this tribe. And that is just a hypothesis that I introduced to make it a little bit more interesting. Yeah. Yeah. So that is what I wrote here. Vegetables have a higher use value than meat in the diet of our tribesmen. Yeah. So very simple world, only 2 professions, hunting and gathering. Both are specialized. And in this world, we will impose changes. Before we do that, let's look at the optimal social division of labor in this tribe. Let's put ourselves in the shoes of our chief. Our chief wants to optimize the use value that is generated in this tribe, the social welfare. Well, let's compute that then. Let's assume there is a K is the number of gatherers in the social division of labor. That automatically makes 20 minus K the number of hunters. So K gatherers, 20 minus K hunters is this making up the social division of labor in this tribe. I can therefore describe the total output that is generated in the social division of labor as 6 units per gatherer of roots is generated. So we get 6 times K as the overall total productivity. And 4 units of meat per hunter, 20 minus K hunters, so 4 times 20 minus K. And so the total productivity is a bundle, 6K units of roots and 80 minus 4K units of meat. Yeah. We divide that equally then over all the people that are in this tribe. I divide by 20 this bundle. I get a consumption bundle per capita, right, as 3K over 10 and 4 minus K over 5. So 80 divided by 20 is 4, minus 4K divided by 20, that is K divided by 5. Yeah. And then I plug that into the utility function, and this becomes then my objective. So I'm maximizing my objective now over K. And that objective is here formulated. I add 1 to 3K over 10, which is the per capita vegetable consumption. And I add 3 to my per capita meat consumption. And I get then 7 minus K over 5. And I multiply those 2 factors. And that is my overall derived per capita welfare in this tribe. Note again, this is a quadratic function in K. and it has a negative multiplier in front of the k squared. And you can see that easily from this formulation. And so we have a maximum. And so the first order condition should indeed lead us to that maximum. With some manipulation, I use the chain rule combined with the product rule. I get an equation 95 minus 6k is equal to 0. I solve that, and I have to round to the nearest integer, of course, because 95 divided by 6 is not a whole number. So I need to round it, and I round that to 16. Yeah. So it's important that this rounding has to happen. So the first order condition will give you the answer, but it is an approximate answer because we have this whole number problem in this particular example. We cannot divide an economic agent into pieces. Now, we plug in 16 into our production function. We get 96 units of roots, 16 units of meat total produced in the economy. And I then divide that equally over everybody, and I get 4/5 units of vegetables and 4/5 units of meat per capita. Plugging that back into the utility function, I derive that I get here 18.24 as my per capita welfare, well-being. And that is then my benchmark, right? So this 18.24 is my benchmark number. I'm going to compare how things change in this tribe, and the performance of that change, or how that affects the welfare, is then benchmarked with regard to that number 18.24. Yeah. I'm going to modify this social division labor in 3 ways: population growth, technological progress is Ricardian, right? So the productivity of a certain profession increases. What will the effect be on the total welfare in the tribe? And then the deepening, which is a Smithian development in the social division of labor. And deepening means I introduce a new specialization, a new socioeconomic role, new goods, and new institutions in all regards to describe this. All right, let's have a short break. Let's take another break of 3 minutes or so. I will be back 11 after the hour, and we can talk about these 3 changes. Yeah. All right. See you soon. All right. I hope not to keep you too long. We will just go through these examples, hopefully within half an hour. Before I start off, are there still any questions related to what I was talking about so far? All right. Then I will just plow on. Let's first talk about population growth. What does that really mean for economic wealth? Because it is not so obvious that this should lead necessarily to major increases of wealth, because social division of labor will not change. The same roles, the same way of doing things. The only thing that happens is that there will be more of everything. There will be more farmers, more hunters, more gatherers. In this example, there will be more hunters and more gatherers. And the only thing that can happen is that you get a better approximation of the ideal socio-divisional layer. So note that the K that we derived in this computation was a rounded number. Now, if I increase n, I can approximate an exact number more perfectly. So that exact number is the same as this lambda that we had in the previous example that I did in the previous lecture. That lambda is the true optimum. And because of the finiteness of the tribe, you have an approximation of that optimum. And what happens when you have a larger population is that you simply can get closer to the optimal lambda, so to say. That does not necessarily lead to a very large increase of wealth. Now, in the example that we have here, by accident that is happening, the increase in the wealth is quite substantial because of the fact that it is such a bad approximation of an optimal socio-divisional labor, this one that we had. Yeah. So we can call this the first order effect. First order effect is that the approximation becomes better. The second order effects are likely much more important. Those are effects later on. When you have an increased population, you get increased diversity. In particular, it will lead to more ideas bubbling up, and this will lead to other developments, the developments that are not necessarily related to population growth. So you would get technological progress and deepening of the socio-divisional labor because you get more people and more people with more ideas. And if these people are diversified, when you have immigrants, for example, with different ideas, with different cultures, they bring in a new flux of ideas into the society. You might get tremendous developments, but those are second order effects. Larger professional classes, by the way, also allow similar things to happen because technological progress can be based on very, very small changes to how you do things. And this can be contributed then to the collective knowledge that we have and that we teach in our educational systems. So larger professional classes will lead to the development of these professions in a more rapid way. And that's exactly what we see, historically speaking, right? So when you get a new profession, if the profession becomes larger and larger, you see more and more development of that profession much quicker than professions that are declining, so to say, and become smaller groups of people having the other professions. Okay, let's return to the tribe. Let's assume there's an increase in the tribe's population of 20%. All the changes that we will talk about are all 20% in some way. So let's have a 20% increase of the population of the tribe. So we go from 20 to 24. Now let's repeat then the computation. Let's now say that the number of gatherers is k again, but now that is a number between 0 and 24. And so we can again compute the overall productivity, but now we have to divide that by 24 rather than 20. So I get k divided by 4 and 4 minus k divided by 6. Because the number is different, it is now 24. Okay, plugging that into our utility function, I get here this new formulation. Using the first order condition, I get an equation 38 minus 2k is equal to 0, and that gives us an exact solution, namely k is 19. And this shows you that an increase of population allows an exact solution to suddenly pop up. The larger the population is, the better the approximation, and you might even have an exact solution on your hand. And in this case, that is popping up. You plug it back into your productivity. You see you get 114 units of vegetables, 20 units of meat. Divide that equally among 24 tribesmen. You get 4 3/4 and 5/6 as the final consumption bundle. Plugging that per capita consumption into my utility function gives me a utility level of 22 1/24. And you see then what is then the increase in well-being compared to the old level, which was 18.24, remember? If I compute then the increase, I get an increase of more than 20%. And that is all based on the fact that I have now a more perfect approximation of the ideal social division of labor. In fact, by accident, for this particular example, it is the optimal social division of labor. You can do an exercise if you want to by increasing even further the population of this particular example to, let's say, 50 or 48, and you will see that if you do that, there will be no gains anymore from this population growth. So the first order effects of the population growth are completely exhausted by this increase from 20 to 24. And that is because 24 allows us to execute this perfect optimal social divisional labor here. Yeah, is that clear? Are there any questions? Okay, so that concludes then the discussion of population growth, right? Even population growth, what is more important is the second order effects, and I'm going to talk about that now, namely technological development and deepening. Let's introduce a tool, let's say a very simplistic tool, a tool that can be made by a gatherer. Let's say gathering becomes much easier with this tool, namely a piece of wood that is shaped into the form of a digger, so to say. You don't need a specialist to develop this tool, right? It becomes a standard tool for a gatherer. And so I'm assuming it is not a deepening of the social division of labor. You don't need specialists producing the tool. It is something that a gatherer will do himself, but it will increase the productivity. So I will introduce a 20% increase of the productivity of a gatherer. So we go from 6 to 7.2 as an output level of vegetables of a gatherer. Yeah. The productivity of our hunters will remain completely unaffected. It is still 4 units of meat that a hunter produces. However, a gatherer can now produce more, 7.2. What you would expect is that the overall wealth in this society will increase and that we will get a modification of the social division of labor in response to this. Yeah. Again, we introduce this variable k. It's again back to 20 members in the tribe, so it is a number between 0 and 20. And I compute now the overall productivity in this tribe as 36 times k divided by 5 units of vegetables, roots, produced by these new gatherers, so to say, these highly productive gatherers, and 80 minus 4k, like we had before, units of meat. I divide that equally among the 20 members of the tribe, and I get a 9k divided by 25 as the number of vegetables consumed per capita, and 4 minus k divided by 5 units of meat. Yeah. Okay, let's plug that into the utility function, and I get this particular formulation of utility function. And we will need to maximize that. We again do the first order condition, and in this time it leads to 290 minus 18k. Again, I round that, and it will lead then to exactly the same number, namely 16, the one that we had before. So the social division of labor has not really modified itself very much in response to this productivity increase. But of course, the consumption increases tremendously, and it goes from what we had before to 115.2. The level of meat production remains exactly the same, and so the consumption per capita consumption of roots increases tremendously, and there's no increase in the consumption of meat. This is all a consequence of the mathematics here. If you do write down a different utility function, you will get a different outcome. Maybe you want to play around with that. Here we have a preference for vegetables, was built into the utility function. If you remove that, it might well be that the higher productivity of vegetable production will lead to an increase in meat consumption also, because more people will specialize as hunters, increase in the meat production. But that, again, that depends on your utility function. And you can play around with those numbers 1 and 3 to get that going. But in this particular example, not much else happens. However, we get much more utility. And as you can see, the increase in use value measured with that utility function goes up with the amazing 40.8% compared to the benchmark that we had before. Are there any questions with regard to this Ricardian example? All right. Let's summarize a little bit what happened. First of all, this refers to the standard way of understanding growth. Neoclassical growth theory is very much productivity oriented. Increasing productivity is always seen as the source of wealth enhancement, growth. I don't agree with that necessarily, because I believe that the deepening and institutional innovation is at least as important, but we will come to that next. But we see here in this example that you get tremendous increases in wealth when indeed you get productivity increases. So this Ricardian basis to growth is very strong. Yeah. Especially when you look at GDP, as it is called, it is always linked to this productivity growth, because GDP is essentially set up for that. GDP is, by the way, a really bad measure of wealth, because it is not value free. It's not based on the commodities itself. It is also based on the monetary system, which is subject to all kinds of forces and is not necessarily a very good way to measure things. This is a source of a lot of debate at the moment, because even though GDP has really exploded over the last decades, it does not really trickle down to normal people. There's a lot of unrest in the economy because the link between GDP growth and well-being of normal citizens is broken down at the moment. And so we get very bad feelings, and that has consequences for political consequences in particular. So we're living in a very restless society. One of the reasons is that GDP growth should not be our objective in the economy. It should be really based on well-being, which is an extremely hard thing to do. In the simple examples already, we see that the utility function is necessary, and that essentially is very unpleasant because it implies making choices what is important and what is not, which is not good. And GDP does not have that issue because it's a straightforward thing. Theorists have worked, by the way, on measuring wealth in a different way. I'm referring to Piero Sraffa, who introduced a standard commodity, as he called that. It's a bundle of commodities, and that bundle of commodities can be used as a kind of monetary unit to measure output and well-being, and measure the wealth that is generated in a social division of labor. And also Sraffa, who is some sense successor of Ricardo in his thinking, although his major work was only published in 1960. Right, he was a 20th century Ricardian economist, a neo-Ricardian, as that is also called. He came up with this idea that you should base measurement of wealth on a very different way than monetary instruments. And this was one way to do it. And there is a slight revival of Sraffa as a main thinker. And I want to point out the name to you because you might read up on that and see how it can shape your thinking about certain things. And it could even be subject of a dissertation, for your dissertation, MSc dissertation, namely this whole debate about GDP, measuring of well-being, measuring of happiness. There's been very little reference to Sraffa in the traditional literature, but in the heterodox literature, as it is also called, it plays a major role. Sraffa is quite an important thinker there. Anyway, it's a side remark. I just dwell on that a bit. Anyway, technological progress, technological innovation, increased productivity from technological progress is an important factor. We focused on that tremendously, and what has happened in the economy in the UK in particular is that this technological progress has been lacking, and there has been a decline actually of productivity over the last decade or so in particular. And this is called the productivity puzzle. And there's a big debate on what the causes would be, and neoclassical economics and neoclassical thinking does not really give you a good handle on this. And it might also, yet another MSc dissertation subject might be, when you start to think of this in the context of the social division of labor, can you maybe develop an alternative perspective on this productivity puzzle? That's one way to think about it. Yeah, and so I'm dwelling on this a little bit here. Technological development, technological capital, right, is very much at the forefront of thinking in neoclassical economics. And there has been an underinvestment in this. That has been identified. Why is that then the case? This is one of the puzzles of our contemporary global economy. Why is there an underinvestment in technology. And this is one of the big puzzles. So one puzzle becomes another puzzle. We just translate one puzzle into another puzzle, and that is a big problem in some sense. All right, so the institutional framework can add a little bit here to understanding that a little bit better. But I will not dwell on it here so much. I will come back to this issue when we talk about entrepreneurship, which is next week actually already. Okay, the next big thing to apply to our tribe is a Smithian deepening of the social division of labor, an institutional enhancement of the economy, and mainly through new products and new professions. So how do we do that here in our tribe? I take the other profession as the main subject to that. I will take the hunting profession and will modify that in a certain way. And the meat production will be done through a supply chain that is deepening, so to say. And that requires new goods, new specializations, and new institutions which do not pop up in the mathematics, right? That it works, which is an assumption of the mathematics. It is just we assume certain numbers to pop up. Well, why is that? Well, the institutions are supporting that. There are good institutions at work, and so the deepening is working out, right? Bad institutions would undermine the deepening and it will break down. This was the case in 2008 with the mortgage provision network, like I talked about last week. Yeah. So that's my last point here, right? Deepening leads to fragility. We become more dependent on each other. A higher level of trust is required, and a higher level of trust can only be done in an economy that is less corrupt, to put it in those terms, and more governed, better governed. And that was certainly not the case in 2008 in this mortgage provision network. So let's return to the tribe and let's talk about the deepening here. Let's take the hunting profession. Let's say a new technique emerges, a better spear is developed, but a better spear requires an advanced way of making that. It needs balanced, to make a balanced spear, you need a high level of technique, a high level of specialization. It needs special wood. It needs the tip of the spear. Metal work is required for that. It needs balancing, like I said, an advanced thing. So we introduce a new profession, a spear maker, so to say, a spear maker who can do the metal working, who can find the appropriate wood, who can identify the appropriate branch that can make a good spear. And so we introduce this new profession, and this leads then to this deepening. We now get a spear maker being part of the hunting provision, a hunting supply chain, so to say, the meat supply chain. And that leads then to a significant improvement of productivity as well. And we again will implement a 20% increase of meat production compared to the original state. Let's do that in a schematic, in a network representation, so to say. So what was the first step? Well, the first step was to have simplistic social division of labor based on hunters and gatherers. I did not even talk about this more primitive society in which everybody was doing everything. So this was a society of a less developed hominin, so to say, than Homo sapiens. Homo sapiens would already be developing their society in hunters and gatherers. and that would be exactly of the type that we talked about so far. Now I'm going to a deepening of this hunter-gathering society, and I introduce now a spear maker. A spear maker will provide a tool, an intermediary product, namely the spear. That tool is traded to a hunter. The hunter will use that tool in the hunt, in the meat production, in other words. And the meat production, therefore, improves tremendously. The hunting becomes much easier. And so we have a 20% increase of the total productivity of this hunting enterprise, so to say. Gatherers are unaffected. We still have gatherers, and of course, the diet is still meat and vegetables. However, the hunting, the meat production now is now coordinated through two professions, spear making and hunting. And pairs of spear makers and hunters, they are now essentially forming a supply chain. And in this supply chain, you assume increased productivity overall. So how do we mathematically formulate that? That is the question that I want to ask. Yeah. Before I do that, I want to emphasize that we talk about institutional development here. This is a deepening of the social division of labor is an institutional development. It is an innovation at a very high level. Namely, you need a new good, namely the spear itself. This needs to be a publicly tradable good. And this is an institutional feature of the economy, right? That we have spears and we recognize spears and we give a name to a spear. That is very important. And spears, when you look at these primitive societies, are extremely important tools. They are also elevated to a level of religious worship. They are forming the basis of rituals, dancing with spears. When you meet other tribes, you would exchange spears with the other tribe. Note that this exchange is not an economic exchange because there are no gains from trade. It is spears for spears, and therefore doesn't add anything to your economy. It is just a ritual, a social ritual of meeting another tribe, being peaceful with that other tribe. And so the exchange of spears is a ritual to be peaceful and to build an alliance, essentially. For certain things that is a good, at some point you can conglomerate your economy, you can get the tribes get closer and closer together, they can become one tribe at some point. There is very little intertribal trade identified in hunter-gathering societies. So I just want to emphasize that here. The spear, when you look at that, how it is used, it forms an extremely important religious symbol and element. The other element is then the role. The spear maker role is an institutional element again. It's a very important element in the deepening of the social division of labor. And all of this refers to Smithian development. All of this Smithian development refers to institutional entrepreneurship. We invent new things. We do things in a different way. Let's return to our mathematical model. I now have three production plants, namely the gatherer. That is unaffected, still 6 units of vegetables, that's all. So no spears and no meat. Commodity 2 now is, by the way, the spear. So the spear maker, S, produces one spear. We assume it produces one spear, and that spear is used by a hunter in the hunt. So using an input is a negative number in the production plan. So -1 refers to the usage of one spare, and the output is 9.6. This is the same as 2 hunters in the original situation with a 20% markup. So in the new situation, with the deepening of the social division of labor, one hunter with using a spear will produce 9.6 units of meat, which is the equivalent of 2 hunters. Remember, there was 4 units per hunter. The 2 hunters produce 8 plus a 20% markup, and that is 9.6. Yeah, so I hope it is clear how we get to these numbers. Yeah. So we see here that when I put together a spear maker with a hunter and I add up those production plans, I get 0, 0, 9.6. And this is exactly the output of a supply chain in this primitive economy. A supply chain consists of one spear maker with one hunter. And this pair produces 9.6 units of meat. So you see here now that having positive numbers and negative numbers of intermediary goods, as we call them, in this case the spear, it balances all away and it becomes 0. And we get this idea that you can model in that way a mathematical representation of the output of a supply chain rather than an individual producer. Yeah, so I already talked about this. Yeah, so one pair of a spear maker and a hunter together produce 20% more than 2 hunters. So when one hunter retrains, so to say, as a spear maker, the productivity overall increases with 1%, with 20%. Sorry. Any questions? Okay. Let's make it work. Again, we go back to our tribe and we introduce again the variable k. However, k has to be even now. So the choices for k are even more reduced than before because we talk about pairs now of hunters and gatherers. Yeah. So 10 minus half k, those are the pairs that when you have k gatherers and k is even, you then get 10 minus half k pairs of a spear maker and a hunter. Yeah, 10 minus half k supply chains, that's another way to say it, supply chains of meat. So what's the total productivity then? It is 6 times k. This is the total output of vegetables. 0 units of spares because we have exact pairs of one spear maker and a hunter. And then 10 minus half k, that's the number of pairs, times 9.6, that's the total output of meat in a supply chain. So the overall production in the economy is then 6k, 0, 96 minus 4.8 times k. Yeah. What is then the total consumption? Well, nobody wants to have spares as a consumptive good. Spares are an intermediary input in the production process. Therefore, we disregard that for our consumption. So there are 2 consumption goods, namely meat and vegetables. And so there's 6k units of meat produced, 96 minus 4.8k units of meat. And we divide that equally among 20 tribe members. And you get then this per capita consumption bundle. Yeah? 3k over 10, 4/5 minus 6k over 25. Yeah. So note that in the social division of labor, the usage and the production of intermediary good balances out. you produce exactly the amount of intermediary goods that are necessary in the production processes. So this is, of course, a more complex production process. We use in that production process one spear. That spear is produced, but it is immediately used. And so it cancels out in the production process. Yeah. I hope that it is clear. The confusing thing, of course, of a spear is that it is a durable good. And this is a timeless model. It's a static model. There is no time here. And therefore, we assume it will vanish. But of course, static is the same as in the long run, right? So long run really is equated to static. Anyway, let's go back to our utility function. We plug in that per capita huge consumption of goods. We get again a quadratic formulation in K. We then compute the first order condition. I got 525 minus 36 times K is equal to 0. And this time I have to round it to the next even number. Remember, because of the fact that we were having pairs of spear makers and hunters, it had to be an even number that we of available people, so to say, for those pairs. And as a consequence, there was an even number of gatherers as well. In this case, the next rounded number is 14. So we get 14 gatherers and 6 persons available for delivering meat. Divide that by 2, we have 3 supply chains for meat production. 3 supply chains. Yeah. Each supply chain producing 9.6. And that is exactly what we compute. The output of this economy is 84 units of vegetables and 28.8 units of meat produced by 3 meat supply chains. What's the average consumption? 84 divided by 20 is 4.2, and 28.8 divided by 20 is 1.44. Yeah. So you see here, we have a significant increase in the consumption of meat in this economy. What is then the utility that is computed here? And you see then that we have a substantial increase in well-being in this economy measured through that utility function. Use value, in other words. All right, any questions about mathematics, about the example? It's all in the lecture notes as well. And of course, you can look at the slides. Exercises, second exercise in the exercise set for this week is explicitly charging you to go through computations of this type to get used to this, to see how it works. And I advise you to really do that. I mean, it's very enlightening to go through these examples and do the computations and finding out about what leads to what and how the productivity overall is developing when you assume certain things. And the mathematics gives a real feel for that. You know, it gives you a real number and it increases so much. And so it is satisfying in that regard to work with these numbers and to enhance your understanding of it. And I really urge you to do that. One final remark that will conclude then the presentation for this lecture is about transaction efficiency. If you produce stuff in the social division of labor, you externalize things instead of having internal processes, right? Of course, before the deepening of the meat supply chain, hunters were, of course, also hunting with spears, but the spears were lower quality, made by the hunters themselves. And now we suddenly had this deepening, and now we had a professional spear maker, an advanced professional much better at doing this. And so the productivity tremendously increased. This was an externalization of an internal production process. Instead of one person making a spear and hunt, you now have two persons, one making the spear and the other doing the hunting. Yeah. So this is very important. Yeah. So what we see then is that this externalization leads then to more transactions, to trade. And this then implies then how efficient is that trade? And that is called transaction efficiency. And that refers to transaction costs. So externalization of production in some sense through a social division of labor leads to transaction efficiency as being a very important element of the economy. And I will refrain from explicitly using transaction efficiency in mathematical formulations of these theories, but instead I will use I will not refer to this at all, except here, and pointing out that transaction costs are extremely important. And I just have to mention one word, and that is Brexit, to point that out. The EU lowered transaction costs tremendously, led to higher transaction efficiency. Brexit reintroduces transaction costs and makes transaction efficiency decline. And this leads to all kinds of very unpleasant consequences. Yeah. So that is, these final slides are about this transaction efficiency, and that this is very much driven by institutions. And Brexit is the prime example of that as well. It is an institutional change that resulted in significant decline of transaction efficiency. Yeah. So that is then captured here in the last phrase. The effectivity of the social division of labor is determined by its transaction efficiency, embodied in the trade infrastructure of the economy, as well as the functionality of the institutions and the heuristics in the prevailing governance system that guide those trades in that trade infrastructure. So transaction efficiency is extremely important, but I will not talk about it very much in this module. You can devote a whole module to this transaction efficiency, but I will not dwell on it too much beyond what I present here today. Okay, this concludes today. Right, some conclusions. Right, we talked about homo dictius. All economic interaction is relational. It expresses itself in trade infrastructures through this main instrument of deepening of the social division of labor. And this deepening results then into much increased wealth. And transaction efficiency is very important in that regard, linking it to the last remark. Yeah. And it is all about opportunities and equality of opportunities and inequalities of opportunities in these networks. Yeah. And it is all linking with the boundedness of our interaction, our abilities. Yeah. Okay, the next week I will talk about socioeconomic spaces, as I call that. This is the understanding of what an economy is, and I will enhance that quite a bit. And I will talk about entrepreneurship. Yeah. Are there any questions at this time?